Good morning, everyone, and thank you very much for joining us for today's webinar, Low Cost is Low Carbon, Practical Design, Materials, and Policy Handbook. My name is Shalika Sivathasan, and I am the Administrative Assistant in the Continuing Education Department at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and who are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin, I would like to share some important information to ensure an effective and professional webinar experience. Please be informed that this session is being recorded for quality and educational purposes. For accessibility, we provide automated closed captioning service available in multiple languages to accommodate the needs of our diverse audience. In order to maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. Kindly note that the chat function has also been deactivated. However, we do highly encourage engagement through our Q&A window, which you will find at the bottom of your screen. Feel free to submit any questions you have for our speakers there. Questions will be addressed during the designated question and answer period at the end of the presentation. For those seeking continuing education learning hours, please note that attendance is crucial. A minimum of 80% attendance is required for these hours to be accredited to your OAA transcript. Please just allow a few weeks for the processing and reporting of these hours. And lastly, please note that the presenters do not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. Now, I'm very excited to introduce our speakers for today's session, Ryan Bruer and Jana Elbrecht. Welcome, Ryan and Jana.
Thanks, Shalika. Good morning, everyone, and thank you for joining Jana and I for the next hour. We're going to share with you the recent learnings that we have had in our research and project work around building in Canada with low cost and low carbon methods. And I think what we've begun to find is just like how we're here this morning doing a sort of maintenance on our own professional skills. We're continuing educating ourselves. There's also a maintenance that is constantly happening around policy, and that's Jana's expertise. And so after I share a bit about some of the new knowledge around designing low carbon buildings and the strategies we can employ as designers, Jana's going to take us through relevant policy updates and some of the work we've done together and with HAF and Clean Energy Canada. And I'll allow Jana, she'll introduce herself and the work that Clean Energy Canada does, the important work to transition Canada to renewable and cleaner systems and policies.
Thanks, Ryan.
Yeah, go ahead.
Yeah, so nice to be at this forum today. I'm Jana Elbrecht. I'm a senior policy advisor with Clean Energy Canada, and as Ryan mentioned, we're a climate policy think tank. We're based out of Simon Fraser University at West, but I'm based in Toronto myself, and we work on all things energy transition and public policy. So happy to talk a little bit more about that in the second half of this session.
And quick intro for HAF. We started HAF 4 years ago and realized that to reduce the construction emissions in Canada, we needed to work together. We needed to raise the bar of education for designers and builders and policymakers. So that's the work we have been pursuing together as a small group of architects ourselves over the past couple of years. And HAF of what? It's we know that all building has a negative impact on our globe. It uses a lot of raw materials and there's a significant greenhouse gas emissions, and our work is how do we halve these emissions and how do we go beyond that? And so today I want to frame our problem as a two-sided coin of the lower carbon and the lower costs. We inherit a fairly rigorous federal policy and federal targets around lower carbon. And for us as Canadians, we don't look so good when you line us up per capita against the rest of the world. And so maybe that's good news. Maybe in order to cut emissions, it should be easier for us as some of the top per capita greenhouse gas emitters compared to our friends in the UK or in Mexico, where shrinking that bar by half would be much greater challenges. I think there's lower hanging fruits for us to achieve. And then on the other coin, we're now on a slow march towards building in Canada and this idea of how do we do it at lower cost. We have really ambitious targets for delivering housing, 3.5 million housing units by 2030. We know there are several initiatives like Build Canada Homes that are seeking to do that. But that's also coming at a time where there is this crunch in we have lower starts this year, and how we're going to get there becomes a little more of a question mark at this time of the opportunity is there to reimagine what might have been fixed. We might have saw the type of development that was going to happen in our country, in our province, as a little more certain than it is now. And I think that's an opportunity for us to reimagine instead of here you can see the proposed projects. This is Midtown Toronto, where the type of density that we imagined seemed certain, and now maybe there's an opportunity for us to rethink it because we know that that not only the method of construction but also our method of planning and development has a huge impact on the carbon emissions of those developments. So here you're seeing, although it's housing for families, for citizens, it's not equal in carbon emissions per year, where density, methods of transportation, and infrastructure all have a huge impact. And on the left there, you're kind of seeing a typical suburban development in Winnipeg compared to other developments around the world in the UK and in South Africa. So here's our objectives here: more housing and reducing emissions. On the one hand, we need lower cost materials. We need regional availability with no supply chain risk. We need to reduce the cost and timelines around design and development charges. We need to rethink density. And on the other side, we need to understand how materials are made, where they come from, and those life cycle impacts. We need to think through durability and the replacement of materials, passive systems, form and efficiency of unit layouts, and then, of course, how it integrates with active transport that's low carbon. And what we want to propose this morning is that I think these can be done together if we design for it. And what we're going to do is share some strategies on how we think of it as when we approach a project at half, and some of the strategy you could take to your own projects. Before I dive in, I thought let's test out the poll function on Zoom here, and you should see now a poll appear, and in your practice, the question is, what's the biggest barrier to low carbon design that you found as practitioners? Is it code, zoning requirements, cost and budget constraints? Perhaps it's on the client side that there's no ambition there, or is it a lack of tools and guidance? Or perhaps this is something that's new for you and your firm, and then the last option would be the selection there. So you should see on your screen you can select a poll, and we'll just give it a second as the answers come in, and we'll be able to see here just a pulse check for who's in the call here with us. And we have a big group, which is really exciting. So thank you for joining, everyone. I think once we get a pretty sufficient response rate, here we go. So you should all see the poll results here. We got 91 poll entries and 2% for code zoning requirements. Cost is this a kind of huge piece, and budget constraints, and the leader being client priorities. I'm excited to see that lack of tools and guidance is not higher up there, and that makes me feel like maybe as a professional, we're doing our job, we're staying up to date. But so I think this is something that we can address in our talk today as we go through here. And ultimately, and so that's where we started. We started, okay, we need to raise the bar in design knowledge. We have the findings, we understand the importance of this, but how do we train more professionals and get it out there? And this was also on the mind of the Treasury Board Secretariat. They wanted to upskill all their project managers, and the goal was to have a primer for low carbon construction. And together with them, we borrowed a bit from the structural engineers out of the UK, and we find this pyramid of low carbon design strategies to be really successful, because you have at the top the most impactful decisions, and you can work your way down this pyramid to make changes on your project. We found that these strategies of build less, build sufficiently, build efficiently, low modern methods of construction and low carbon materials, they actually mapped pretty nicely onto our phases of the project. Because just like cost, as you all know, you want to make those big decisions up front and you want to stick with them, because changes late in the game have high cost. It's synonymous with how we think about the carbon impacts too, where inefficient structures and unfortunate product substitutions can have a big impact. So we took that strategy to map those onto the project phases, and drilling in even further into the project phases, we want to address how can we ask the best questions at the right moment to get the outcomes we want. So from very early on, you can ask those really important questions about existing assets on site. Is there an opportunity for renovation to extend the life of the building that's on site? And what we found when talking with project managers is that there are a lot of newer option analysis tools and reports that can be produced by consultants that are interrelated, that will inform key decisions on how to best make that decision. So, having an energy audit and a whole life buildings life cycle assessment really gives you the full picture of the kind of carbon profile. And so this kind of flow chart here, we produced a few of these for each of the project stages. The idea was how to explain to project managers how these reports interrelate so that they can optimize their decisions on how to set the right kind of goals, and ultimately, if required, how to right size a new construction if that's the path that was taken. So let's talk a bit about build less. What do we mean by that? And I think the best way to describe this is about unlocking the value of existing buildings. It's about extending the life of a building, of the kind of carbon bank that we have within our cities. And so the study went through three options. We did this work with the Canadian Association of Heritage Professionals. And the goal was to understand how these three scenarios would play out in three cities across Canada. So we had Halifax, Montreal, and Vancouver. And we had different scales of buildings. We had this larger apartment building. We had what it would look like for a single family home, whether you'd demolish or retrofit. And then likewise for a lower rise mixed use and residential building in Montreal. And what we consistently saw play out was that for each of these, when you run the numbers on the cost, when you run the numbers on the operational emissions and cost, and then that what you find is that unsurprisingly, the doing nothing is not so good. We have buildings that are high emission, they're expensive to run. We need to upgrade them to suit our needs. But also on the other side, demolishing and replacing was actually a higher emission activity, and it didn't provide the cost benefit that we were expecting. And so this was consistent across all the sites and designs, where the demolish and replace in some cases was actually slightly higher cost overall than the retrofit and addition option. From a circular design perspective, this accomplishes what we also, as a secondary goal, want. We want to avoid waste streams. Demolition waste is a huge issue, and as an example of this, in this Montreal example, 290 dumpsters full of avoided landfill just by doing the retrofit and extension addition option. So you like the way we do maintenance on our buildings, Cap, we were trying to frame this as a way of doing maintenance on policy, because the problem is the National Energy and Building Codes are a bit more prickly when it comes to alterations and reuse. And the purpose of this research was to accelerate code change to standardize renovation in the National Building Code. We have exceptions in few municipalities across the country, but the goal is to get in there and start repairing essentially some of the codes to allow for this kind of work. And it's a long process, and it takes time to make these kinds of changes. And repair is like that, right? I thought I'd just, as a bit of an anecdote, it's a chancy situation, repair, and repair it's always a disruptive intervention in an intricate system. And really interestingly, on screen, we have two very famous disasters, building disasters, but these were essentially from mismanaged maintenance, right? So the bungled routine system test at the Chernobyl plant is what led to the nuclear meltdown in the 80s, and more recently, the Notre Dame Cathedral. That fire was caused by a repair that was happening in one of the spires. And so, we know and I think this is one of the challenges when it comes to code changes is we have a very complex system, and we don't want to get in there and move too quickly and break things. So in order to not break things when you move into with a building, you want to understand all the pieces at play. So there's a measurement that takes place. And at HAF, we're doing this too. We're trying to develop better ways to ask how heavy a building is, to assess a building for what's there before we move in and start to make changes. This is a part of our work that we exhibited at the Lisbon Architectural Triennale and at Design TO more recently. We developed these scans of cultural facilities in Lisbon with the goal of understanding how heavy are these buildings, what's the physical weight, but then also what's the environmental weight, because we understand, of course, the materials within a building have far-reaching impacts, and so whether it's steel, like it's a shot of my hometown in Hamilton, brick, stone, buildings are the consolidation of physical material on one site, and so the first question has to be measurement. And ultimately, I think what we're finding more and more as professionals is that our work is, although it might have previously been seen as innovators and imaginers of the new project on a pristine site, we really are more often now caretakers of the existing context. And I think that's a healthy way for us to really think about our practice. We are stepping into this world where everything exists, and it's about us kind of management of that asset. And that really was one of the findings we had in Lisbon. So sufficiency is sufficient. It means having enough quantity to meet the need. So I kind of distinguishing that here. So when I talk about build sufficiently, compared to building efficiently, which means producing the maximum result with what you have. And so we believe that sufficiency is the first question. And there's no better example of sufficiency than thinking about the average household size, which over the past 100 years, the average household has gotten larger for less people. And Canada, we're top ranking average house size per capita. While we know there are extremely livable, beautiful, excellent places around the world that people live in far less space, this also plays out at the urban scale. And we saw this with work we did with Northcrest in the Downsview redevelopment, that the master plan, as it was coming together, Northcrest asked if we could take a small sample area size and start to play around with the right-of-ways to understand, can we meet the traffic needs, the transportation needs, and still deliver on the design intent. And we began tweaking some of these block shapes and right-of-ways, and you can't really see from the diagram necessarily. It's not even visually apparent, the small tweaks. But what you're able to deliver statistically is more housing, more green space, and less road to maintain, while still delivering a thriving, rich urban environment. And ultimately, this speaks to this kind of ongoing realization that this infrastructure burden is getting carried by municipalities, and we need to start considering that more closely when we think about delivering housing. So then, moving on to building efficiently, a good example of this, how do we maximize the use of what we have? We did some work with the City of Toronto on their urban design guidelines. They wanted a fresh look at what's driving carbon behind some of the decisions that are in here. The first step was, this is a genealogy of the urban design guidelines. It's not a fixed standard. It's something that's evolved over time, and there's this legacy of renewal and modernist thinking around the block. And our challenge was, how do we maximize the block? How do we to use it for its best use? And we've had some really ambitious aspirations around these urban design guidelines, like lighting, daylighting, for example. And what you'll see is that and I kind of like this comparison where these designs were drafted up. This is around one of the oldest churches in the city of Toronto, Metropolitan United. Not exactly what came to fruition, where you have larger buildings ultimately in the end. So the implementation of this policy didn't exactly play out. And I think what we found is that, unfortunately, it has driven and continues to drive a type of building that is higher carbon and higher cost. This is your kind of typical wedding cake mid-rise building, the City of Toronto, that has had these strict setbacks applied to them. And what you see here in blue, orange, and gray is that each part of the building is not the same when it comes to embodied carbon. There are the residential system, the kind of typical floor, has a fairly low carbon footprint, whereas the ground floor has to do a kind of acrobatic structural design, and then of course below grade has a kind of higher carbon embodied upfront carbon to it. And this is being driven by many things, some completely necessary, but some that I think we need to readdress. And part of the study was, okay, what if we didn't have these setbacks? And the reality is, if you don't have them, you can deliver more housing, and you can more efficiently distribute the services of that building within the building. And we're pleased to know that this work has gone on to make to inform policy changes. The city of Toronto, they have reduced some of the daylighting requirements, and so it's encouraging to see. But there's still a lot of these policies across Ontario in municipalities. I'll just stay on this one more thing, and a kind of an aha moment for us was the type G loading. We have waste management services that are fairly large. They are not this large in every city across the world, but we have to manage some pretty large trucks. And ultimately, the requirements of the kind of interiorness of the waste management just blows out these kind of ground floors and leads to the kind of structural requirements for transfers and the like, in addition to kind of other asks we have of the ground floor. And ultimately, you can see here the study we did with General, where the blue represents all the space allocated just for the turnaround of the type G loading requirements. So we're very excited to see that this work is getting taken up in the conversation, because there's a lot at stake, where our beloved storefronts along, the iconic streets of Toronto really are at risk, because you can't program the kind of narrow, ideal retail spaces when you have to develop large sites with large parking, large waste management. So you can kind of see this overlaid here, where you're going to end up with more. You just have Shoppers Drug Marts all the way along here, probably. And so we're excited to see that the city actually approved a review of the type G loading requirements very recently. So that's underway right now. Working our way down here. Building with modern methods often refers to prefabrication, offsite construction, digital technologies, and those all apply. One more I'd add recently is the CMHC Housing Catalog, which is an exercise of delivering more advanced, more knowledge more quickly across the country. The housing catalog has gone through iterations over the past century, and the most recent one attempts to deliver in the hands of home builders and small developers accessible drawing sets and designs that has, in our case, carbon and energy use assessments already baked in. It allowed us as a design team to put together more efficient, more optimized designs, so that doesn't need to be a question for people looking to deploy this in the cities more quickly. And there were some pretty one of the most interesting things about this exercise is that you realize that the baseline is not the same across the country, particularly around material choices, supply chain access, and the assumptions around the HVAC systems particularly had a large impact, where on the left you can see in Manitoba the assumption around using an electric system, air source heat pump, would lead to very low whole life carbon. So that's what we've done, is we've had side by side the kind of operational energy here, and then the embodied carbon, that's the upfront carbon on the right hand side, and on the bottom, and together over the life of the building, you can see that the upfront carbon really is the piece we need to pay attention to. In Saskatchewan, when you make the assumption that it stays on natural gas even as a new build, the upfront carbon becomes dwarfed, and really the operational emissions become the imperative as far as reducing the emissions of that project. And so here they are side by side, we call this the whole life carbon profile of the building, drastically different. And this immediately tells you which things you need to pay attention to make reductions. And of course, nowhere's the same, where in Manitoba and in Saskatchewan, you have a totally different electricity grid profile, and and emissions in Manitoba are quite clean versus Saskatchewan. So that has also a kind of huge role in doing these assessments. So yeah, we were pretty pleased to be a part of this evolution of the CMHC guide. And interesting to see when you look back, some of the decisions that around materials that have changed over time. So in 1967, when we talked about rigid insulation, and I've got a lot of text here, but at the bottom here, right, rigid insulation could be made from wood, vegetable fibers, mineral wool, and then of course you have your polys in there too. But if you zoom over a couple decades up to 2013, rigid insulation now is exclusively board materials such as polyisoanurate and expanded or extruded foam plastics. So somewhere in there, within 40 years, we somehow lost the language of vegetable fibers, wood fibers, and mineral wool. And so one of our chief goals was to get some of those low carbon materials back into the menu of these buildings. And our material guides was an attempt at that, to provide builders with a very quick lookup sheet for types of materials. So all the way through insulations, membranes, cladding products, to show that they're not all created equal, and to provide the kind of cost and carbon narrative in a very easy to look up manner, and we also included a kind of relative life cycle cost, a sort of assumptions based on the replacement cycle of each of those products. So as an example here, just kind of products you'd be very familiar with, but trying to demonstrate that some need to be avoided rather than others. And in this case, we're talking about choosing a better material for our design. But as a bit of a transition over to Jana, that's not always the strategy. It doesn't necessarily always need to be the strategy. You don't have to throw out all the other materials and go and find materials exclusively made of straw. There can be opportunity to build with low carbon materials by making substitutions for a better version of the same material. And so I'm going to hand it off here. But as I do that, we'll go into poll number 2. And when you think about reducing embodied carbon in a project, what's your instinct? Is it to swap a different lower carbon material? Is it to find a lower carbon version, the same material? Can you just reduce the quantity of the material used? Or perhaps you haven't had a clear approach to this yet. So you'll have the poll there. You'll see the options. I'm going to stop sharing my screen, and Jana's going to take it over here.
All right, thanks, Ryan. I'll just, let's see. I'm not seeing the poll anymore, so maybe Ryan, you can tell me if we've got the results.
Okay, the results
here
are
it is.
coming in. Yeah, you got them there?
Yeah, so what I'm seeing is swap to a different lower carbon material as the #1 choice, and then find a lower carbon version of the same material as a secondary choice. So I think we got some more work to do on that pyramid, Ryan, to drive home the importance of reducing the quantity of material used as well, which is coming in 3rd here. But this is great. We'll talk to a few of these options. So as I mentioned in my intro a little bit, what I work on is public policy, not architecture. I should not be allowed to design any buildings. So in the second part of the session, I will give a little bit of a public policy perspective on embodied carbon. So how can policy requirements help us reduce emissions from the building sector? How can this have an effect beyond the building sector, and look at some of the tools that have been used so far by the federal government, mostly by the federal government, and where some of the opportunities might be. So when we look at Ontario's emissions profile, you can see in the orange here, construction itself makes up 2%. So this is like the on-site emissions, which is a notable chunk of the pie here. But of course, the building sector itself is one of the biggest emitters. And this, of course, is when we're talking about building or burning natural gas or heating oil to keep our homes warm, to keep our water warm, to keep our offices at a comfortable temperature. And designers can have an influence here, right? We can build more energy efficient buildings. Project owners and clients can have a huge influence here, deciding to go with a fully electrified building. But what I also want to talk about a little bit more is the ways that the building sector and architects specifically can have an effect beyond their own sector. And that is this huge chunk of our emissions profile that's made up by material production sectors. So these are the steel plants in Hamilton, cement plants, some of the manufacturing, lime and gypsum, etc. And of course, the emissions from what we produce in Ontario don't cleanly align with the materials that we built with because we import and export. But worldwide, this is also a big slice of the pie. So about 5 years ago, I believe, we at Clean Energy Canada were working on industrial decarbonization. How can we use government policy to push the cement sector, the steel sector to reduce their emissions? And we looked at a lot of supply side solutions. How can we help with innovation, technology development? But another really important piece of the puzzle is the demand side solutions. How do we create a market for lower carbon alternatives? And what we found at the time, and these numbers are from, I believe the study that we did was in 2022. So the exact numbers would be a little bit different, but we found that public construction accounted for a third of the market for cement and concrete and for construction steel. So if governments for public projects start asking for lower carbon materials, that will create a very strong market and demand signal, pushing those sectors to make investments to clean up their production processes. And so this is how we started thinking about this policy instrument called Buy Clean. And we've been doing a lot of work on it since. We did a big report quantifying what the emissions reductions would be of doing this as at a whole of government approach. We looked at some of the things happening in the US, mostly at the state level and under Biden at the federal level at the time, and in Germany and what we could learn from that. And we've done a lot of work with the construction sector, talking about what implementation of these kinds of policies would look like. So let me give you a little bit of an overview in the last few years, what has happened, what has changed. Quite a lot has happened at the federal level. We saw the Green and Government strategy, which was the Trudeau era strategy to clean up the government's own operation. So there's great requirements in there for the fleet of cars that the government has, but there is also a big part on buildings. And this is mostly lives in the standard on embodied carbon in construction. And it applies to direct procurement. So any building or infrastructure that the government owns and buys directly. So think about an office building, for example. And as of September last year, some new requirements were added. So now there are requirements to use lower carbon ready mix concrete in any of these projects, to use lower carbon structural steel, and for Part 3 buildings over a certain budget threshold to reduce the whole building embodied emissions by 30%. So this is a reference case methodology. So this is really great. This is really moving that market of direct federal procurement to incentivize the sector to start thinking more about embodied emissions. But as you can see with this iceberg on the side, and this again is from our 2022 study, so exact numbers would be a little bit different, but the proportions probably very similar, is that a lot of spending as you all probably know, a lot of spending doesn't happen at the federal government level, but it's municipalities that buy infrastructure. It's healthcare and education organizations that buy those buildings. It's crown corporations and provinces. So one other thing that's been under development is where the federal government does fund infrastructure, but through these other levels of government. So one example is the Canada Housing Infrastructure Fund, which now does have a requirement. So they transfer funding to municipalities from the federal government to build infrastructure supporting of new housing. And there's now a requirement for lower carbon concrete in that as well, kind of mirroring that standard on embodied carbon. But more needs to happen at these other levels of government as well. So there's some municipalities that have done some work. Toronto with the Toronto Green Standards. Vancouver has been a real leader on this. But of course, Toronto is a little bit in flux right now with some of the things happening around green development standards. But yeah, that's a bit of an overview of what has been happening in this space, which, we're overall pretty happy with. And the federal government has also done a great job supporting some research, including the guide that Ryan showed previously that HAF worked on. What else is going to happen in the future? Well, I can't tell the future, but what we're hoping to see is some more requirements on federal infrastructure funding. The province in Ontario has been a little missing in action on this file, so it would be great to see some provincial requirements. But then another very important development that's forthcoming is the national model codes for 2030. So the 2025 national model codes, which were published recently, had these operational embodied carbon requirements in them. But now for 2030, there's also a working group working on embodied carbon. This is still very much in the development process. So if this was something that you're interested in but weren't aware of yet, I would highly recommend going to the CBHCC website and also looking at some of the open meetings that are happening. But what it looks like now in the most recently updated policy position that was published is that this is likely going to cover A1 to A3 phases. So the material production for the structure and potentially the envelope. That's still TBD. And there might be a tiered approach, same as with operational carbon and energy efficiency requirements. So giving the room for provinces to step in at different levels of ambition. So it's still a whiles away because obviously the 2030 national model codes then need to be translated into the Ontario Building Code. But for any of you who might not be retiring in the next 5 to 10 years, this is an important development that every architect's practice is going to have to start thinking about. But whenever we advocated for any of these policies and all of these policy developments, we keep getting this question, right? And this is also what came out of the first poll. What is this going to cost us if we are going to use lower carbon materials? Is that going to break the bank, make our project unfeasible, make housing more expensive? And so we did some research on this. This report we published last year, about a year ago now, and 2 weeks from now, we'll publish a little bit of an updated, expanded analysis on this. So we'll give you a little bit of a sneak peek today. It's still not public until May 21st. But what we focused on in this research on what the cost implications are is when we go back to this pyramid, it's the kind of the bottom of this pyramid. So importantly, as Ryan said, some of these earlier stages actually do have higher impact and are usually lower cost. But once you get a project going, and with policy, we're a little bit more thinking about how can we build more efficiently and how can we build with lower carbon materials. So when we look at lower carbon materials, importantly here, we're looking at like for like swaps. So we're not comparing a steel structure with a mass timber structure. There's lots of cool research out there on that, but this is more what if we used lower carbon concrete. We built the same exact building, but we just change our concrete supplier, and we use a concrete mix with some fly ash mixed in or some steel slag. So the way we did this is we worked with general contractors to use real world buildings, existing buildings. In the two studies combined, there were 12 case studies across 6 provinces. The large group were multi-unit residential buildings. And we looked at the project as built, the material quantities in that, and we basically re-estimated what would a lower carbon equivalent for these materials look like, and what would that cost. So this is a bit of an overview table combining the 2 stages of the study. Our report to be published is currently being designed, so please excuse some of my not perfectly centered graphics. Our graphic designer is working hard to make it more beautiful. But like I said, some of the things we're looking at here for alternatives is using SCMs in the concrete mix, using recycled steel and electric arc furnace for rebar, using bio-based alternatives for insulation. Here, sometimes it is a little bit of a different material for insulation, but we definitely made sure that it had the same performance. And we found a wide range of options with different levels of emissions reductions. And in most categories, not really a significant cost impact. I'll switch to the graph here because I know some of you might be more graphically inclined. So we see a huge clustering around this y-axis here, right? There's all these different levels of embodied carbon emissions that can be achieved with no cost increase. Sometimes we found that an estimate for a lower carbon concrete came out cheaper. All of this is on a per unit of material basis, both emissions reductions and the cost impact. So when we look, for example, at the highest instance of a green premium that we found for concrete, this was 16%. The emissions reductions, I actually don't know off the top of my head. It looks like about 15% as well. But this is 16% on a per cubic meter of concrete basis. But to put that into a little bit of perspective, this was concrete used for the foundation, and it came to 0.55% of the foundation's budget, and 0.035% of the total project budget. There are some outliers here of very high premiums. So these are both rebar. Sometimes with recycled rebar and electric arc furnaces, there can be a bit of a constrained supply chain right now, not enough supply for the demand. So that's likely why we're seeing these instances of the estimate coming in at twice the price of higher carbon rebar. But the neat thing about public policy is that you can account for this, right? So the standard on embodied carbon that the federal government has a little bit of an escape valve where if your lower carbon steel comes in at a premium above, I believe it's 2%, but please check the policy for the number. I believe it's 2% of the structural budget. If it exceeds that premium, you don't have to comply because obviously we want to use lower carbon materials where they're reasonably available. And in most cases, they are. So yeah, what we always say is just ask. Most of the time, we're not using lower carbon materials because we're not even asking if they're available. But to kind of move back up that pyramid, we also, especially in a public policy space, we wanted to talk about the fact that there's all this interest in using lower carbon materials, great, lower hanging fruit, but there's even more that we can do in the design phase. So we, again, looked at real world case studies, buildings. Half did this work with us. 3 of them were in the GTA, and then now for the new iteration of the research, we added one in Montreal. And this is just to show what can we do with earlier interventions in terms of reducing the use of materials, which can reduce both the embodied carbon and the cost of the building. So I'll just quickly run through some of these, but for more details, please have a look at the report. So we looked, the first one are these townhouses. So we looked at 4 interventions here, which together added up to about a quarter embodied emissions reduction. So one of them was this envelope, right? So this is a block of, I believe it was 6 townhouses in a row, and they had these little pop-out windows to visually distinguish one from the other. And here the research consortium looked at what if instead we visually distinguish these units by using colored bricks or a brick pattern. Then we can save all the steel framing and cut about 9% of the emissions. They also looked at, for example, sloped roof, which on the upfront emissions doesn't have the most enormous effect, but over the lifetime of the building, it might avoid replacement of the materials. So this is also, again, thinking a little bit higher up in that pyramid. How can we build more efficiently over the lifetime? And then this one we'll see coming back again and again. I think Ryan already mentioned that obviously below grade construction is one of the most carbon intensive things we do, with all of the shoring, all of the concrete required. And to give you a more striking example of that, perhaps, this is our mid-rise design case study. So here there was this, I want to say, quite enormous parking garage below ground. And here the team looked at what if we brought that above ground? And they found that by doing this, there would be the same number or even a little bit more parking spaces. Same for the housing area. But these different interventions together reduced the embodied emissions again by around a quarter. And this is really from, not building underground. Saves a really thick concrete slab, saves a lot of excavation and shoring. And as a little co-benefit here, they ran a neat little calculation of how many trucks of excavation volume we're talking about with a building like this. And this is a building in downtown Toronto. It's actually quite close to where I live. I walk by it all the time. And just to think about, what 2,500 trucks does to the traffic on that street. So other co-benefits to think about, also about construction timelines here. Sometimes building underground can really prolong that timeline. So if we're talking about affordable and quick build out of housing, these are some of the things we can think about. And we work to quantify some of those material savings, because you're not only saving emissions by using less concrete, you're also paying for less concrete. Last one here was the high-rise design case study. So this is also a little bit to do with those urban design guidelines in Toronto, because one of the things, of course, there's this remassing, the simplifying of these different levels, which made a huge contribution to embodied emissions reductions. But another thing are these 3 different layers, right? There's an underground parking garage, then there's the retail level, and then there is, I think there was about 600 housing units in here. But because they all had different grids, different structures, and they weren't aligned, the pillars weren't aligned, they required huge transfer slabs. So one of the things the team looked at here was, what if we do align those levels? What if we shift I don't remember the directions, whether it was from southwest to northeast, or what if we move the tower from one corner of the building to another and we align those layers? You can get rid of 22% of the concrete and 13% of the rebar and not having that transfer layer. Those are huge material savings, huge emission savings for the same function of the building. And this is for the envelope, so simplifying some of the outside. There's, again, more details in the report, but I'll have to wrap it up soon. So I'm gonna inevitably send you to our website. And we did one more recently in Montreal in our newest report, showing how material efficiency and design can work together to achieve 30% reduction in embodied emissions, 40% reduction in costs by removing the basement, thinking a little bit more about what the envelope looks like, and using lower carbon concrete, recycled rebar, etc. And we also really want to show that savings are best achieved through a combination. And when you use less concrete, you can pay a little bit more per cubic meter of concrete. So even where there is, take that highest premium that we found, even if you pay 16% more per cubic meter of concrete, if you use less concrete overall, you got that room in the budget. So thinking about this early and in a more integrated way is crucial. I'll quickly run through some of the things coming up in our new research around infrastructure. So HAF works with Hatch to also look at some roads, showing that if we use reclaimed asphalt, if we maybe depave some of the side sections, if we use lower carbon concrete in the concrete elements of our roads, we can hugely reduce the carbon embodied in our roads, and at most of the time, it actually reduces the cost. Another thing to think about is water infrastructure. So material choices. In Ontario, we use different materials for stormwater pipes, sometimes concrete, sometimes plastics. Optimizing those for carbon can have a bit of an impact using lower carbon concrete in these catch basins. Just different parts of our infrastructure that we can think about reducing embodied carbon. We looked at water treatment plants, and again found that you can use lower carbon concrete, lower carbon steel. Most of the time, we did cost estimates for this as well. Most of the time they came in at around the same price. But I'll leave you with some takeaways. And yeah, looking at the poll, it's very interesting to see that so many people are thinking about lower carbon materials, either swapping out a material or using a lower carbon equivalent. And this really is a great low-hanging fruit. We can already use lower carbon concrete quite easily in a lot of projects. But don't forget that pyramid that Ryan showed you. Design and planning decisions can often have a larger impact and can help with some of that cost question, especially with some of the infrastructure case studies that I showed you. It's great to use lower carbon materials for a pipe, but the biggest predictor of the embodied carbon in water and road infrastructure is how much road we need to build per person, how much water infrastructure we need to build per person, whether that's a single family home subdivision or a more high density neighborhood. And yeah, it's coming down to pipeline in the codes. So definitely, if you haven't started thinking about embodied carbon yet, you have a few years to really wrap your head around it in your practice. So I think with that, I'll move it on to our Q&A part of the webinar. And our contact details are on the slide, so always happy to stay in touch.
Great. Thanks so much, Ryan and Jana. As Jana mentioned, we are going to shift into the Q&A portion of the webinar now. So if you haven't already, please make sure to type your questions in the Q&A window. You'll find that at the bottom of your screen. I actually had a kind of thought or question myself that I thought maybe we could open up with. I really liked some phrasing that Ryan used in the beginning of the presentation, talking about architects, maybe I think it was sort of seeing themselves as imaginers of the new versus shifting into a mindset of being protectors of the existing context. I think that was the phrasing that Ryan used. And speaking of that, again, kind of taking a look at that second poll that you guys shared, where we had architects and our members saying that they were thinking more about swapping materials versus reducing the quantity of materials used. So I feel like maybe swapping materials is more aligned with kind of still building new and still thinking about, creating new buildings versus reducing the quantity of materials used. For me, sort of aligns more with this idea of protecting what we already have and kind of reusing what we already have. So my question, sort of following all that, is to what extent do you both find that those in the field of architecture and those in government as well are kind of welcoming of this shift in perspective from imaginers of the new to protectors of the existing and what we already have? Is that something that people are kind of resistant to, or are we sort of embracing that more and more? Just in sort of your experience, what have you guys seen?
I mean, I can speak from the public policy side a little bit that, and this is probably the same for architects, but for definitely for government, it's more exciting to cut the ribbon on a new bridge than to restore an old one, right? So I think that's a little bit of maybe a mindset shift that we need to think about what do we already have. And there could be cool policy solutions for that. I believe it's in Paris, but I don't have a very precise um, so please fact check me on this one. But I believe it's in Paris where there is extended responsibility um, for the construction sector. So if you want to build a building on a site where there is a building already there, you're responsible for there's some requirements on checking what materials that are already there you can reuse. And so I kind of asking that, prompting people in their projects to think about that. If you buy a plot and there's already a building there, great, that's some free material for you. What can you do with it? And finding ways that we can do that cost effectively.
Oh, Ryan, you're muted.
I've been kind of obsessed with Stuart Brand recently, and I think he says something like that's the kind of paradox of maintenance is that it's absolutely necessary to survive. Like that's what we do. All biological creatures are mostly concerned with maintenance, but then it's also weirdly optional, and especially for buildings, like we are very selective with how we maintain buildings occasionally. Kind of famously in the heritage world, like demolition by neglect is a kind of phrase. But yeah, I think to your question, I think people are excited about this, and what I have seen generally from clients, even working with government um, departments like Global Affairs Canada, if they can, they will. And I think for us, we're always it's about envisioning how that's going to be possible, perhaps demonstrating how the existing asset can provide what they're looking for, and it can do it in a way that has the kind of specialness of a ribbon cutting. Because I think Jana's totally correct there, right? The repair a retrofit doesn't have the same kind of yes, glamour. So that's a challenge, but I think for us as visualizers and I think that's something we can take on and get people excited about.
Great, thank you both. So we have a question here. So someone begins by saying, great presentation. And then they say, I agree with the strategy of build less to reduce carbon. However, if a client or project brief directs us to reduce carbon, it is easy to demonstrate reductions achieved by swapping one material for another. But how can we demonstrate the reductions of building less?
Great question. Generally how we've approached it is there's a little bit of an exercise where we will model the brief as it stands, which is a demolition, and then maybe model the retrofit as another alternative, and then showing the delta between those two, so you can kind of tell the carbon story that way. Of course, producing a report like that can be time that architects don't have. So, I'd be happy to, please email me afterwards, and I'd be happy to point you to reports like this one that I showed from the Canadian heritage professionals. That would be something you could fairly easily point a client towards, and just, if it's something perhaps they have a ill-conceived, like a preconception about the cost of a retrofit, then I think those we can kind of fix that misconception.
Jana, I don't know if you wanted to add anything too.
Yeah, I think on the build less, I think there's part of it that's maybe more on like a city or society level and part of that is within a project. Um, and I think the first part, like I said, thinking about how much road we're building per person, how much water infrastructure, that's maybe more of the prerogative of city planners. And but once you have a project and a client, it gets more into that part that Ryan talked about, thinking about how do we build less with what's already on the plot. Um, yeah, and I think this piece of research that they just published with the um, showing that difference between doing a retrofit scenario, doing a little bit of a mix, or doing a full demolish is a great example to show how it can be done. So I think showing some of those examples can maybe spark some inspiration in a client's mind on how can we, and I think sometimes actually using the cost cutting frame proves more effective than using the carbon
Mm,
frame because if you frame it as you could be really nice to the environment by building a lower carbon building. Realistically, most project owners are like, that would be nice, but I also want to have a good bottom line. So it's going to be the first nice to have that gets thrown out of the project versus if you already frame it from the start as we can use what we already have, or we can design a more lean building and it will cost us less, then I think you're going to spark a lot of interest that way.
right. Essentially, emphasizing that relationship that low cost is low carbon, right? So hopefully that message comes across. Great. Thank you so much. So, okay, we have another question here. So, in studying the inverted pyramid of high impact to low impact approaches to reducing carbon emissions, I note that the quality of durability and flexible design for adaptive reuse does not appear. For instance, if the life cycle of buildings and materials were required to be 200 years rather than 30 to 60 years, what would be the impact?
Yeah, great question, Barry. Those challenges kind of sit between, for me, modern methods of construction and low carbon materials. In that flexible design, I would say, is a strategy that you could consider it a circularity strategy, right? It's in a way it's future proofing the building so that in 60 years, when the new owners and new occupants are trying to improve or do different program, they don't need to demolish it. They can actually it's much more obvious that it's flexibility, it can adapt. So I kind of see it fitting in there. And then the durability could be in modern methods, but also could be in low carbon materials in a way in that, it's drilling into the specification of a product, and but then also thinking holistically of like an assembly. So I think of I don't know if the 200 years versus 30 years, or no, it wouldn't quite be the asphalt shingle roof versus the metal roof, but be more like 5 to 10 years for the asphalt shingles versus 60 years for the metal roof. Right. That would be a low carbon and a low cost question. I know anyone who's ever got a metal roof quoted for like a single family home it can be quite a shocking price. But if you know that if you're gonna own that building for the 60 years, you're gonna have to do the shingles however many times. It's always sooner than you think, right? Yeah, that's where I would see that fitting into that triangle there.
Sure.
Yeah, but
Jana,
I,
any?
I think what's interesting there is that the incentives aren't always aligned because it makes a lot of sense if you're the owner operator of a building, but if you build it and then pass it on, then it's like, you want to just get it built for an efficient budget and then can pass the cost of replacement down. So, yeah, it's interesting to think about how we can put that responsibility a little bit more on the person building it or not person, but the organization building it in the first place.
Mm, that makes sense. Great. And then another question here, is there any education planned for contractors? Oftentimes, it's not a question of design or materials, but lack of qualified trades/GCs and their ability to actually understand detailing specified products and not price the project out of the market as a result. So I guess where do contractors fit? into this equation?
I have a little bit of an answer on that. So as part of the research we did, we worked with general contractors, and it was actually a great opportunity for them as well to see some of this data on their own projects that they could have used lower carbon materials. And so I know from the people within those companies that we worked with that they have been using some of the results internally as well to convince project managers that this is something they could do. So hopefully I can help with a little bit of that education. Then there's also for some lines of product, so for lower carbon concrete, sometimes by now it's been many years of using supplementary cementitious materials like fly ash, but I think especially earlier on, there's a little bit of, is this going to work the same way? Is this going to provide the same strength? And there can be a little bit of a reluctance to change. So definitely something that needs to happen on the contractor and the trades level. And I think organizations like the Cement Association of Canada are putting in some of the work to provide some of that education. But a really good point that, sometimes change is hard just because it's change, and education can help with that.
For sure. Ryan, I don't know if you have anything to add to that question.
No, I think that was a good. I mean, we'd like to see more would be my answer, but it's maybe that's the next group we try to engage.
Great. Okay, perfect. So someone has asked, would you consider the Danish grain silo conversion by Kobe Architects a good example of carbon reduction? I guess they're referring to a specific project. I'm not sure if you both are familiar with that project.
I know, I just did a quick Google.
Oh.
Cool project. I'd say this would be one where right off the bat, you're retaining structure that sees new life. There's all that concrete there that would have otherwise been rubbled. I'd have to learn more about the trade-off of the kind of metal cladding, aluminum balconies. It's with any building, like sometimes there's a bit of a trade-offs with the LCA and the life cycle assessment. But it's certainly a nice looking adaptive reuse project, that's for sure.
Great. Okay, perfect. So someone has asked here, early historic buildings were designed to be rehabilitated and adapted over time. Many contemporary low-carbon building components do not appear to consider this level of long-term repairability or reuse, which can ultimately affect the LCA of new buildings. Is there a reason why this approach is less prevalent in newer low-carbon building components?
And I'm thinking here, yeah, there's the kind of speaking of maintenance, some of these newer products can be hard to repair, maybe is what this question's getting at. Highly specified or highly kind of maybe complex. The triple glazed aluminum clad wood window is maybe harder to repair than the old wood windows that were in a ways designed for any homeowner to be able to repair. Kind of like a Model T versus a Rolls Royce. I'm not sure. Yeah, is there a reason? I guess for me, it's that we really want our new low carbon, high performance buildings. They're really trying to do a lot, and I guess this is where my mind goes with your question, Jason. It's just that we're asking our low carbon buildings to be extremely high performance, and sometimes that gets in the way of the kind of operability, repairability question, and I don't know if I have a solution for that. off the top of my head, but it's a really good observation.
Yeah. Jana, anything you'd want to add to that?
No, I think it is right that we're rightfully, but we're asking a lot. We're asking for new buildings to be constructed cheaply and fast and to be energy efficient and electrified where possible and lower embodied carbon. So um, it's a big challenge. They're all for good reason that we're asking for these things, but big challenge ahead of us.
Mm. Something to continue thinking about, I guess, as we move forward. Great. Thanks so
I actually
much.
just I thought I'd just add one point to that because I know it's just something I've been thinking about a lot recently is the kind of right to repair argument, and there is a lot of that going on. Not really around buildings though. So maybe there's an opportunity there to for architects to have a bit of a right to repair initiative. But if you're not familiar with it, it's the kind of there are cars are a big one, right? Where you have these kind of products. Our vehicles, we used to be able to be repaired in our driveways, but now that's totally impossible. And sometimes it's actually larger companies inhibit that intentionally to kind of take advantage of their capture of the market. So yeah, maybe architects we need to be more pro right to repair for buildings.
Yeah, and I think that's something that is being thought about in the prefabrication space quite a bit. If you have a building that's made out of prefabricate, I don't know why that word's so hard, prefabricated components, if one of them breaks or ages out, can you just swap out the component?
Great. So room for more discussion on that, I guess, at a later time. But great, thanks so much. Okay, and the last question we have right now in the Q&A, although of course, if you are still typing your questions in or you still have one that you're thinking of, please put that in the Q&A window. But this person has asked, is there a list of the most popular sustainability features that building owners look for when considering to buy an existing building? I'm not sure if this is something that you would have off the top of your heads or if there's a resource that you are familiar with, but um, any thoughts
I
on this
go
one?
back and forth on certifications. Sometimes it feels like a total hindrance and checklist, but then when you do think about communicating with building owners, they can be really helpful. Yeah, so without having a list, Ian, maybe talk to me after. There's definitely ones I feel more important, but when it comes to like having that conversation with the owner, you'd want them to be aligned with, and excited about whatever initiatives to kind of make it a sustainable project. So yeah, sometimes that certification is the way to go to have that conversation.
Yeah, I think especially for a client who might not be in the business of building themselves, could be easy to use something like LEED or some of the standards that the Canada Green Building Council develops to signal that you've thought about all of these different parts of operational and embodied and energy usage and all of the different parts because they keep developing new versions of these standards and crystallizing what's important and how we combine these different things. So that might be an easier way to get the whole package and signal that you tick all of these different boxes.
Mm. Okay, great. And we have one more question that came in. So they've asked, in a context where our various levels of government are turning to alternative project delivery methods for their projects, for example, IPD, how can we establish conditions that promote a limited carbon footprint while also systematically considering project costs and speed of delivery?
I can
That's a
kick
good
it off.
question that kind of gets at the tension there. I think what I've seen is that we just need to have the kind of carbon requirements beyond carbon too, but as performance metrics in the contract and What I've heard is that's happening with some of the newer Bill Cannon Homes RFPs. And I think that's going to be the best way to do it. You set the goal from the start, and then the teams have a way to work towards it for each site.
Yeah, I think it can definitely provide opportunities. Something like IPD, if it means that everyone is at the table earlier on. And we've heard this through a lot of our stakeholder engagement from, for example, general contractors, but also from designers, that if you're pulled into a project a little later on and you're like, oh, I wish the materials would have been spec'd differently. I wish we could have made this change in the design. Then you're missing all of these opportunities, all of these windows to bring it back to that inverted pyramid, to earlier on in the process start thinking about carbon, like Ryan said, to use it as a metric from the beginning. So I think some of these new delivery models do offer that opportunity to think about that from the start, how those different parts fit together. Because sometimes it will mean, if you use a slightly different material, that's going to affect what's happening on site. So it's great to have everyone who's involved in those different parts as part of the conversation from the beginning.
Great. So that's all the questions I'm seeing now. Of course, again, if you are still typing, feel free to input your question in that Q&A window, but we are almost at our time. So I'm going to go ahead with my closing announcements. But again, if any last minute questions come in, we can still address them at the end. But I'll start off with just my announcements, which is first, of course, a huge thank you to Ryan and Jana for being with us here today and sharing this really important presentation. We had some great engagement from our members. I know they've learned a lot. And Ashley has put Ryan and Jana's email addresses in the chat. So if anyone has any questions or wants to get in touch with them directly, you can do so. And Jana, I just seen that you have shared your report there as well. So feel free to check out those resources that you see linked in the chat. Okay. Thank you, of course, again, to all of our attendees for your engagement today. So for those, again, who are seeking continuing education and learning hours for this webinar, the OAA will record your participation on your OAA transcript, so there is no need for individual reporting on your part. Again, we just kindly ask for your patience at this busy time of year as we process and confirm the accreditation of your hours within the next few weeks. Attendees are going to soon be receiving a copy of the slides from this presentation, as well as a link to a survey to submit your feedback for our webinar. We at the OAA and our presenters highly value this feedback, so if you do get a moment, please complete that survey once you receive the link. So we have a bit of a break between now and our next webinar, and that is because next week from May 13th to 15th, we have our OAA's annual conference in Waterloo, Ontario. This year's theme is Collaboration Powering Innovation, and if you haven't registered yet, not to worry, there is still time. Online registration for the conference closes on Monday, May 11th, and there will be on-site registration as well in Waterloo on May 13th and 14th. So there's still time to register if you haven't. You can find the conference program and registration links on the OAA website, and we really hope that we will be seeing many of you there. So looking forward to that next week. Our webinar series will resume on Thursday, May 21st. We have a webinar titled AI as Design Collaborator, Beyond ChatGPT for Architecture. So feel free to sign up for that one as well. And of course, for a list of our upcoming webinar offerings, check out the Continuing Education Webinar Series page on the OAA website. I don't think any more questions have come in. So again, a huge thank you to Ryan and Jana. Thank you to our attendees. And with that, I'll wish you all a pleasant remainder of your day. Thanks very much.